So here what's going to happen is, so suppose you take reciprocal of 1. What is the reciprocal of 1?
0.
Reciprocal of 1. 1.
1. Right. Okay.
Reciprocal of 2.
1 upon 2.
1 over 2. Reciprocal of 3.
1 upon 3.
Reciprocal of minus 1.
Minus 1.
Reciprocal of minus 2.
Minus 1 over 2.
Reciprocal of minus 3.
Minus 1 over 3.
So when you plot this, so therefore so you're right. So there'll be a vertical asymptote on the y-axis.
Yeah. And a horizontal one as well, right?
And the horizontal one as well. So your vertical asymptote is your x is equal to 0. And your horizontal asymptote is
Y is equal to 0.
y is equal to 0. So 1, 1 is there. Yeah, 1, 1.
Yeah.
Correct? Acha. What is it? 2? 2 is what? 2 is half.
Yeah.
2 is half. Correct? 3 is 1/3. Acha. Half will be 2. Half will be 2. Correct?
Yeah.
1/3 will be 3.
And 1 would. Yeah.
So like this.
Very cool.
Acha. Similarly, minus 1 reciprocal minus 1 is minus 1. Reciprocal minus 2 is minus half.
Right.
Approximately I'm putting it.
Which is
This
the
is
horizontal?
minus 1/3.
Yeah.
Acha. Reciprocal of minus half is minus 2. Minus 1/3 is this.
And the arrow faces down. Okay.
Yeah.
So your horizontal asymptote is at y equal to 0?
Yeah, horizontal asymptote is x-axis, y
Yeah.
equal to 0.
And then your
Vertical asymptote is
x equal to 0.
x is equal to 0.
Okay.
That's
Yeah.
vertical. So this is how you can know how far or how close it is.
Right. Okay.
Huh?
This is a bit wrong, I think.
Yeah.
But I knew the general idea.
Yeah, general idea you know.
Yeah.
Okay. So the graph of this is what is it called? A hyperbola. This is called a hyperbola.
Hyperbola, right.
Okay. Domain
X can be equal to 0.
means x belongs to set of real numbers, x is not equal to 0.
Yeah.
Range.
Y cannot be equal to 0.
Equation of the vertical asymptote.
X is equal to 0.
Horizontal asymptote.
Y equal to 0.
Correct. On the same set of axes for question is sketch a graph of 4 upon x.
Okay.
So this is what will happen when you do that.
Right.
So 4 upon x when you do. So x, y. So y is equal to 4 upon x if you take.
So then
So if you take 1,
becomes
1 is 4.
Yeah.
Correct? 2,
becomes 8.
2. 4 upon 2, no? 4 upon 2.
Sorry, I'm not sure which point you're talking about. Oh, 4 upon 2. Oh, let me split 4 now. You've taken 4.
4 over x.
4 upon x, right.
My function is 4 upon x.
Right.
So when I take x as 2.
Okay. When you take
Correct.
x as 2.
Now when you take x as 4, what will your y be?
1.
1.
Okay, I see what you're doing.
Correct. So now if you take x as half, what will y be? 8. Correct. Huh?
Yeah.
And so on. Now let's take some negative. So if you take minus 1, minus 4.
Minus 4.
Correct. If you take minus half,
minus 8.
minus 8. If you take minus 2,
minus 2.
minus, because you're putting.
Right.
So let's plot this.
So that's how you just find it. You just
it's better
find
than
new values.
Yeah, find new values. So if I try to plot it here in this graph. I'm not able to zoom in. Okay, so what do you have in this case is minus 1, minus 4.
Yeah.
Minus 1, minus 4. Okay. Then let's take all the minus value. Minus half, minus 8. Minus half, minus 8 will come all the way down. Correct?
Yeah.
Minus 2, minus 2. Minus 2, minus 2. Correct?
Yeah.
Then if I take minus 4, it will be minus 1.
Yeah.
Correct? So this would be over.
I feel like I'll remember this.
Similarly, this part also. So
Yeah.
you'll have half 8, which is way up. Half 8 is like basically way up.
Yeah.
Correct? Then you have 1/4. 1/4. 2 2. 2 2. 4 1. And so on.
Yeah. Okay.
Minus 2 over x. What will you do for minus 2 over x?
There will be a flip over the x-axis,
Correct.
and then
So
you
how do
multiply
you get the point? So basically your
same thing.
same thing,
So write all the x
but rather
values.
so it will come here and here.
Yeah.
It will come here and here.
And you'll figure that out by
Yeah.
plugging in the points, right?
Now the next thing is, you figure it out by plugging in the points.
Yeah.
Now consider function y is equal to a upon x minus h plus k. Based on your previous work, how do you know the graph relates to y is equal to a upon x? So how is from a upon x, how will you get this?
Through a horizontal and vertical translation.
Correct.
of
So
the
horizontal
x and h.
translation.
Yeah.
So how much is the horizontal translation?
It's x to the right,
Correct.
k
Horizontal
up.
h units to the right.
Yeah. K units up.
And k units up.
That's the way you say it, right? K
Correct.
units.
Correct. So what about the domain and range? So what will happen to the domain now?
The domain would be affected obviously by
So x-
h.
X is not equal to h.
Right. Yes. Because it lies on the h. That h.
Correct. It went to the right.
Yeah.
So that basically this which was there, your x is equal to 0. It
It
went
become
to h. It will become h is equal to h. I
If
mean,
it's the
whatever
one,
they
if
do.
it's if it's -1, it becomes
Yeah,
1.
minus 1. Range
Range would be affected.
y is not equal to k
K.
because it went up. Correct? Yeah.
As in, like, okay, wait.
So x is equal to h
Yeah,
and y is equal to k.
because it moves one up. Okay, right.
It moved k units
So
up.
that means, yeah, okay.
So that's your asymptote. So your vertical asymptote will become x is equal to h,
Yeah,
and your
And
horizontal asymptote will
why
become
is it? Okay, nice.
to draw a rational function of this form y is equal to a upon x minus h plus k. First thing is you draw first step.
Right.
You draw asymptote x is equal to h, y is equal to k as dot index. Okay.
So 1. You draw one at 1.
Yeah, in this case, yeah, in the third example, 1
Yeah.
x is equal. Plot points to the left and right of the vertical asymptote.
Okay, so
There are
then
two branches of the hyperbola, so that passes the plotted points and approaches the asymptote.
usually like 3 points.
Okay. So include it as 2 clear points per branch. 2 points per branch.
2 points per branch, so 4 points. Okay.
State the equation of the asymptotes and all that we have to do. So
Okay.
first what we do?
So first you plug the asymptote, which is
so
at
first
1.
what's your vertical asymptote?
Vertical asymptote is equal
X
to
is equal to 1.
x is equal to 1. Yeah.
So at x is equal to 1 we have the vertical asymptote.
Yeah.
Correct?
And
Then
we
your
do-
horizontal asymptote.
So you do plus 2.
So y is equal to
Y
2.
is equal to 2. So that means if you have a graph coming from here, it can't go below this. So it would
No, it won't go below
it
that.
would have to go like this.
Yeah, it will go there. But the point is the graph will either be here and here or here and here.
Right. Okay. And the minus would affect that.
Yeah. So now that you can come to by plotting the points.
Right.
So now what you need to do is take the points on the right of the asymptotes, right and left.
So 2 and
So
0.
so what do you want to take? X is equal to what will you take? X is equal to 2.
X is
correct?
equal to 2, and then he left
Well,
as well,
take
right?
2 on the left. Take
So-
2 on the right.
Okay, 2 and 4.
So X is equal to 4. So now what will your Y be? Find it out.
So you plug in
So minus 3 upon 1.
1,
correct?
1, yeah.
Plus 2. So
Plus
that's
two.
minus 1.
Minus 1, yeah.
So 2 comma minus 1.
Yes,
2 comma minus 1 complete.
right.
Acha 4.
4
So minus 3 upon 3. Correct?
minus 3 upon
4
3.
minus 3
1
plus 2.
plus 2. Minus 1 plus 2 is 1.
1. Correct?
So
4
4 comma 1.
4 comma 1. 4 comma 1.
And that's all you need.
That's all you need. Like this.
Nice, okay.
Now take 2 points on the left.
So then you could take minus 1, no, minus 2.
Minus 1 also you can
Wait,
take.
no, yeah,
can
minus 1,
So if you take minus 1, y is equal to what?
minus
3
0.5.
upon minus 2, correct?
Yeah,
Plus 2, so minus and minus cancel 1.5,
1.5,
so
yeah.
3.5,
Yes,
correct?
yes.
So minus 1 and 3.5, minus 1 and 3.5,
Yep. And then you can take minus 3,
minus 3.
so that becomes 3.
So y is equal to minus 3 upon minus 4, correct?
Yeah. Oh, right, yeah.
Plus 2, correct?
Right,
So
right, right.
2.75.
2.75.
So minus 3 and 2.75.
Okay, very nice.
You can also take your x as 0. If you take your x as 0, what will y be? 5.
Minus 1, 3 plus 2, yeah, 5.
Then you get your intercept. You also got your intercept.
You need your intercept?
Yeah, better if you get the intercept right.
Okay.
Alright, so this is anyway 3.
You can only have an intercept if there's a vertical,
Yeah.
horizontal
No,
translation.
nothing like that. You substitute.
But then
To
if
find out the x intercept, you put y as 0. So if you
Yeah.
put y as 0,
but then here
listen. If you put y as 0, you'll get this.
right.
Then you solve for x basically.
But then for this function, you put 0 as undefined.
Yeah, it's
That-
undefined.
that-
Yeah, therefore we did. So these are my working. So what's your horizontal asymptote?
Horizontal asymptote. In
Y
this
is
case,
equal
with
to-
y is equal to 2. Yeah.
Vertical asymptote?
X is equal to 1.
Domain? X
Domain.
belongs to set of real numbers. X is
So
not
x
equal to
cannot be equal to 1.
correct?
Yeah, 1.
Range?
X cannot be equal to 2.
Yeah. X cannot be equal to 2.
Yeah.
Y cannot be equal to
Yeah. What is this?
Yep.
Some numbers calling me.
Yeah.
Hello? Okay.
2. Any questions?
No questions.
That's very
Straightforward.
Sure, now do this.
Okay.
Okay, so you're right. You did absolutely fantastic job by doing what?
Multiplying
So
by
you
x.
have this. You have this. So you multiply and divide by x minus 1. So this is your x minus 1. This is minus 3 plus 2x minus 2.
Mhm.
So 2x minus 5.
5 upon x minus 5.
Okay.
Yeah.
Fine. Next,
Okay. So you're
same thing. So how do
first.
how do you find out the asymptotes? How do you
So-
find out vertical
So
asymptote?
first, your horizontal asymptote is minus 2.
No.
Sorry,
Vertical.
your vertical asymptote is x equal to minus 2.
Yeah, x is equal to minus 2.
Apologies.
Horizontal.
Horizontal.
So horizontal asymptote of y is equal to, in such form, coefficient of x in numerator
Yeah.
upon
Upon.
coefficient of x in the denominator.
Okay, so that's 3 upon 1.
Yeah.
So
Hyphenation
3.
in this case, so a upon c basically.
This is A. This is
This is
C.
a and this is c. So a upon c.
Okay.
So you have 3 upon 1.
Let me write that.
So coefficient of x in the numerator upon coefficient of x in the denominator. So domain, what will your domain be?
So your domain would be x cannot be equal to minus 2.
Range.
Y cannot be equal to 3.
So let's do that dotted line.
Wait one sec. So horizontal asymptote is equal to coefficient
To find out
Y.
the x-intercept, you put y is equal to 0.
Yeah.
So find out the x-intercept, put y is equal to 0. Cross multiply. 0 is equal to 3x plus 3. So x is equal to minus 1. So minus 1 comma 0.
How did you just get rid of the x plus 2? Oh,
X
because you
plus
did
2 is
0
zero,
times x
0
plus
times
2.
x
Right,
plus
okay,
2, yeah.
sorry.
So minus 1.
Minus 1. Okay.
Then you take any point on the right. So let's say 4.
4. Okay.
So if I take 4,
That's
so
15.
y is equal to 4 3s are 12.
12 plus 5, 15. Upon 6, 4.
So 15 over 6.
Yeah.
3 5s are 3 2s are
So
6.
that's 5 upon 2. Yeah.
So that will be, what did I take?
You took 3.
4.
Oh, sorry.
4.
Yeah, 4.
4
So
and 2.5.
4 comma 2.5.
4 and 2.5. 4 and 2.5. Just similarly, you can find the x-intercept. If I have to find the x-intercept,
So then you plug in
y-intercept. Put x as 0.
X is 0, right?
So 0 plus 3 upon 0 plus 2. So that's how much? 1.
That's 3 upon 2, 1.5. So, okay, nice. Okay. And there's
Yeah.
only one x-intercept, right?
One x-intercept, one y-intercept. Yeah,
Now, now I need to
you can
reflect
take
this.
any other point.
Yeah.
So you have to take the points. At
Okay.
So
But
let's
like,
take two.
there won't be an x-intercept on this side?
No, there won't be
No.
x-intercept
Okay.
on that side.
So then you can
So you
take
take your x as what?
minus 4 or minus 3.
Minus 4, okay. So if you take x as, I will reject this one because there's no space.
Right.
So if you take your x as what?
I don't know, minus 3,
Minus 3.
minus 9 plus
So
3.
y is equal to minus 6, correct?
Yeah,
Plus 3 is minus 3 upon minus 1.
right.
So that's 3. Correct?
Mm-hmm.
So minus 3 comma 3. Right? How can it be minus 3 comma 3?
I think you did it wrong because
I did it wrong because this is minus 3 minus 9. So minus 6.
if you wait, yeah, minus 6
Ah.
plus 3 minus
so 6
3
basically.
upon 1.
So minus 3 and 6. It's minus 3 and 6.
Wait, how? Because minus 9 plus 3. Yes, it's minus 6. Sorry. Yes, you're right.
Correct?
Yeah.
Then you take x as what? Take any other value.
So minus 5,
Minus 5. So y is equal to minus
15 plus
plus
12.
Correct? That's
Yeah.
minus 12. Upon minus 5 plus 2 is minus 3.
Yeah.
So 4. Correct? So minus 5 comma 4.
Mm-hmm. Minus 5 comma 4. Nice.
This is how you do.
It's very easy. You just have to remember this thing is. I can remember that.
So, question 5 to make a conjecture for the domain, range, asymptotes and all that. So tell me, that we did already. So what's your
Domain is
so
y.
first of all, get your vertical asymptote.
So vertical asymptote is a upon c.
Don't write a upon c.
Coefficient of
So
X,
y, that's your horizontal.
numerator.
Y is equal to a upon c.
yeah.
You can't say a upon c. Y is equal to a upon c.
Y is equal to a upon c. Right.
You could say y is equal to a upon c. Then
Then vertical is x equal
so
to
you have to take the denominator equal to 0.
yeah.
Correct? So x is equal to minus b upon c.
Right. Okay.
Okay.
And then
So domain is written from your vertical asymptote.
from the vertical asymptote. So you write
So
x
excluded of
x is equal to d upon c.
X is not equal to
Not equals sorry.
yeah.
Not equals
So
to
you
minus.
exclude the vertical asymptote. and you exclude the horizontal distance.
Okay.
Okay.
Straightforward. Yeah.
Your long distance calling plan. Okay. Next, sixth question. We follow this now.
Yeah. Follow. Yeah.
Your long distance calling plan has fixed monthly fee of 4.95 and a cost of 5 cents a minute. Write an equation for the total cost of the call during a month in which you make m minutes of call. So what will it be?
Fixed monthly cost of $4.95 was 5 cents a minute.
So 4.95 is the fixed call, fixed
Yeah.
charges,
Mm-hmm.
plus 5 cents per minute.
Right.
Now 5 cents is $0.05,
Right.
correct? Into m,
Into M.
correct? Because for every minute you're paying 5 cents.
Right.
So if you are making n minutes, how much do you pay? So obviously you will multiply.
Right. So then you
So
can just
total
find
cost
some
will
value.
be your fixed call plus that.
Yeah. So that's your equation.
That's your equation
Yeah.
of the total cost.
Total cost. Yeah.
The average cost C in dollars per minute a month you make of month. Average cost, how do you find the average cost?
So average cost you do
Is the total call
total cost.
upon n, the minutes of call.
Right. So
Correct?
that'd be 4.95 upon 0
upon
upon
n.
N. We don't know what M is, right?
But we don't know n. No, n is
Right.
in the numerator.
Right.
N is the number of minutes you make.
Right.
Graph the function from okay. After how many minutes the average cost is below 0.10. So let's do that.
Okay.
So how will you graph this now?
So you could take some values for M,
So your x will be your m,
right?
number of minutes. This is your average cost, C.
Yeah.
So what's your vertical asymptote?
Your vertical asymptote would be M.
Okay? M is equal to 0.
M is equal to 0, yeah.
What's your horizontal asymptote?
The coefficient,
Yes.
so 0.05, yeah.
The coefficient of x in
Yeah.
the numerator and coefficient of x in the denominator.
Yeah,
So coefficient of
0.0.
x here is
Yeah.
x means m in this.
I was looking for X, I couldn't find X.
yeah.
Yeah.
So
Because
it's
I
M,
thought of
you know,
4.95, but yeah.
So C is equal to 0.05.
Okay.
5 cents is 0.05. So this is 0.1.
Very small.
Yeah, 0. Half of this.
Yeah.
Correct?
Oh, it's a small graph already.
Yeah. Now what will you do?
Now you can take
Take
some
some points.
points. So you can take like 10,
10, 40.
40, 70, yeah.
So if you take your m is 10,
T is, no, M is
10.
10. Yeah.
so C will be what? 4.95
95,
plus 10 when you do 0.5.
0.5, yeah.
Because one decimal will shift from you
Upon
multiply
10.
upon 10.
So that'd be 5 upon 10.
So now, how 5 upon 10? 4.95 plus 0.5.
Oh, sorry. Wow. So that'd be
So
5.45.
upon 10. Correct?
Yeah.
So 0.545.
Yeah.
So 0.545.
0.545, yeah.
And then 0.545. Somewhere here I put it. All the way up.
Okay.
0. Approximately I'm just putting.
Yeah. Then you
Now
can
you
take 50.
50.
Yeah.
M is 50. So your cost would be how much? 4.95
95.
plus 50. 5
Yeah.
5 is at 25.
So
250. So 2.5
2.5, yeah.
upon 50.
That's
That's how much is it? 0.5. 9 and
6.
5, 14. Correct?
Yeah. 7.
7.45.
45 upon 50.
So then how much is this now?
That is.
You know, you can make this, you multiply by 2. Correct?
Yeah. That's 14.9 on 100. So 0.149
So 0.149. Yeah.
divided by 2.
Right, by 2.
Times. Oh, so then now that's 100.
Yeah.
Add 100 into that. Okay.
Sorry.
You You only need 2 points. Wait, no. Because you times it by 2, no?
Why do you times it by 2? Why do you times it by 2?
I'll show you. Right here. Here you times it by 2, right?
So I multiplied this by 2. So 7 2s are 14. Correct? And
But doesn't
45
that
to 2 is 90.
change? Doesn't that change the?
Upon 2 into 50 is 100.
Oh, so 14.9 is here. The 0.149 is at that point at 100.
So this is 0.1.
Huh.
So this is 0.15. It's little below 0.1.
Okay, but how can you just multiply it by 2?
I multiply the numerator denominator by 2 so to make the denominator 100.
Okay, so it
So I
doesn't
can-
change
it
the
doesn't change
equation.
the fraction.
Uh-huh.
So that
If
you
you
have to
just
just
change
place
the
a decimal.
denominator, then it would be a problem.
So changing the numerator denominator.
Okay. Makes sense.
So now they are saying that after how many minutes of call does the average cost per minute fall below this?
So you have to 0.10
So
equal
you wanted to fall below this.
yeah.
So what is this basically? Okay.
After
No, but my graph is not proper. So if I'm
so
doing
we
it
should just
algebraically,
equation
equation. Use the but look at my graph. Means the average cost means your C should become
0.10.
0.10. Correct?
So then you use the equation.
So 0.10 is equal to 4.95. 4.95 plus 0.05 m upon m.
Mm-hmm.
So 0.10 m minus 0.05 m is equal to 4.95. Correct?
Yeah.
So that 0.05 m is equal to 4.95. So
Then
m is equal to 4.95 upon 0.05. That's
times that by
495 upon 5. Correct?
yeah.
5 nines are 45.
That's 495 divided by 5, right?
Yeah, 495 divided by 5.
That'd be
495 divided by 5. 5 nines are 45.
so then 9.
45 and 9.
Yeah, 99.
99.
Yeah.
So my graph is not correct. So this should go here, 99. So it should cut here further. So the graph.
It's because it's
Yeah. Because point 1, point 1 is here, not this one. Here. 99 here. So my graph should go like this. So basically 99. If you make more than 99 calls, then correct?
yeah. Nice.
Sure.
Was that question 5?
Yes.
That was question 6.
7.
Okay. Look back at your work for.
So can you use the graph to figure out to rewrite this equation in this form? So you suppose you have the equation in this form and you have to split in this form. Can you do that?
Would you have to divide the 3 by x plus 2?
Yeah,
Or you have to sub out the 3 first?
Yeah.
Make it 3 and then x plus 1 upon x plus 2?
So what you can do in this case is, see in this case if I give you, correct? What's my vertical asymptote? X is equal to h.
Right.
What's my horizontal asymptote?
X is equal to a upon
Y is equal to k.
k.
In this form, your x is equal to h is your vertical asymptote and y is equal to k is your horizontal asymptote.
Oh, right. Because
In this form,
because there's the
yeah.
horizontal.
This is in this form. Now in this form, when you look at, what's your vertical asymptote?
Minus 2.
X is equal to minus 2.
X is equal to I need to.
Your horizontal asymptote?
Horizontal asymptote? You don't know.
Y is equal to 3.
Oh, yeah.
Coefficient
3
x is
upon 1.
3 upon 1. So y is equal to 3.
Oh, so then you know
So
it's
therefore your
3.
h, so h is by minus 2, correct?
Right. And your
K is 3.
yeah. K is equal to 3, yeah.
So y is equal to a we don't know, correct? Upon h we know as what?
2. X minus 2.
Correct.
Plus 3. And then can you plug in a value to find a?
Now how do you plug in the value to find a? Now you know that your 3x plus 2 plus a, if I take the LCM, basically this should be 3x plus 3. Or else rather than doing
I'll-
that, I'll tell you one shortcut here. Why we are going all the way around. You can find A basically. But what would I do is, if you want to do this, you do long division. You know how to do long division?
Of course, yeah. Ah. So then that
3.
3,
So
3x plus 6
subtract.
minus 3.
Okay. So y is equal to quotient plus remainder upon divisor.
Okay.
So
So
y is
quotient
equal
is
to 3.
3 plus
Remainder.
remainder is minus 3 upon x plus 2.
Yeah.
So that's
So
one
basically
of
this
the
would be
0
minus 3.
upon. You just know it's minus 3.
Yeah, but that's what I'm saying. You do it this way. You do long division.
How do you know it's minus? Because of the remainder.
Yeah. Do this method. Method 2. You divide it. Huh?
Huh.
Then your y is equal to quotient plus remainder upon divisor. So this is your quotient. Huh? Plus
Yeah.
remainder
Yeah.
upon divisor.
But then how come it's minus? Because then if you do this correct, you do 3 minus 3, that's 0. Then
No,
zero.
but LCM will come in. What? Suppose you want to
Ah, right. Then becomes 6 minus 3.
So 3x
Okay,
plus
okay.
6 minus 3 upon x plus 2.
I see. Yeah, sorry. I was like,
So like that.
Okay. Alright, that's.
So that's how we convert from this form to this form.
It's a bit strange. So wait, let me just re-clarify, right?
No.
You first, you take this x, 3x plus 3, and
Yeah.
you sub out the 3. Oh no, you first find your horizontal and your vertical axis.
No, don't do that. Do method 2 directly. You do
So you
long
just
division.
divide it.
Just
You do
divide.
3x plus 3 divided by x plus 2.
Yeah.
And then your remainder is that other number
Yeah.
that's there.
Yeah. Quotient
And
plus remainder upon
Quotient
divisor.
remainder. But you'll have to find your horizontal
Yeah.
vertical
But,
after.
after
But-
that you can.
Yeah.
But
Okay.
it's better to do method 2 basically,
Alright.
rather than to try
Right.
to do what
All
is trying
that.
to say.
Mhm.
Can
No,
you
we
use
did-
algebra? This is
we
what
did
I'm
that.
doing. Now can you use algebra to show? So
Because this was saying look at the graph, but
yeah,
that's
yeah.
you won't
But
do
that's too much.
that. Too much.
Next lesson.
Next, I already sent it to you.
Oh.
Yeah.
So as noted in the previous lesson, a rational function is a function of the form fx is equal to px upon qx.
Right.
The px and qx are polynomials.
Right.
The word rational is used to, in this case, to suggest that the function is a ratio of two polynomials.
Okay.
Last time we looked at the rational function whose numerator and denominator were linear. What do you mean by linear?
Like
Straight
linear,
line, straight
line.
mx plus c.
Right.
So that means my numerator was ax plus b,
Mm-hmm.
linear. My denominator was also linear. But in general, they can be polynomials of any degree.
Right.
Rational functions can be complicated to analyze because there are many possible shapes of graphs for a rational function.
Right.
Now, this is what is this?
This is
Linear upon
square.
quadratic. Yeah.
Quadratic. Yeah.
This is linear upon linear.
Linear upon
This is quadratic upon quadratic.
Right.
This is also quadratic upon quadratic. So all the shapes can be there. So match the rational function with the correct graph. It's okay to use the calculator, but try out first. So now linear upon linear. So this is something you know.
Yeah.
So which one will this be? You think? This is linear upon linear. You know.
Yeah.
So you know the vertical asymptote.
So 1.
X is equal to 1.
X is equal.
to 1.
Sorry,
So
I
x
keep
is equal to 1.
X is equal to 1.
Yeah, x is equal to 1. That's only one x is equal to 1.
So that's the only.
Yeah.
one X is
So this is
and
your
both of those are linear.
linear. So this is your first one. Correct?
Okay.
Then acha, now here what's my vertical asymptote?
Which one?
This one what's the
2.
vertical? X square
Can it be also minus
4.
2?
Yeah. So
Ah.
x minus 2, x plus 2 is equal to 0. So it has two vertical asymptotes.
Right.
X is equal to 2 or x is equal to minus 2.
Right.
So 2 and minus 2. So
So
here.
that could be B.
So minus 2 and 2.
Oh, okay. So it's very chill.
Yeah. So this
Mr.
is
York
your-
wasn't here, so
Yeah.
we had to like
Figure out on your
figure out on my own. I thought that, but I wasn't sure.
Okay, B. Correct?
Yeah.
So this will be.
And then C.
This one,
1 and minus 1.
x square plus 1 is equal to 0.
So it can only be But
no,
then
no,
wait,
no equation, no.
no
We-
equation.
So no vertical asymptote.
No vertical asymptote.
So that's A. This is this. It doesn't have a vertical
Because this
asymptote.
has no asymptote.
Ah.
Right. Okay. But
This
how
one-
come this doesn't have an asymptote?
Because it's you'll get a
1 squared plus 1.
So x
Oh,
square,
1 squared
x
plus
square
1.
is
There's
equal to
no,
minus.
there's
Huh.
no value you can put
Yeah,
for x that
yeah,
can make
correct.
it equal to 0.
Zero,
Okay,
yeah.
understood. Yeah.
So it's a complex number, no?
Right.
I comes in,
Complex
no?
number, right?
Yeah.
Oh wow, yeah. I know that
Achha.
guy.
This one,
And then
vertical
cross-
asymptote.
Yeah.
So the
Vertical
last one.
asymptote 2.
So x
No.
square plus 4x is equal to 0, correct?
Yeah. So
Remove
about the
x
x of minus 4.
Remove x common. So
So
x is
0
equal
and
to 0
minus 4,
or x is equal to minus 4.
which is d.
X is equal to 0, x is equal to minus 4, which is b. There's no other option. But then also figure it out.
Yeah. Nice.
If there are two equations with the same asymptote, no? Then you think of the x-intercept and the y-intercept.
If they have the same asymptote,
Like suppose you get two graphs with asymptote as 1.
right?
X is equal to 1.
Right. Then you look at the vertical asymptote.
Then you know
By
the
doing-
x-intercept and y-intercept.
X-intercept and y. Okay, so then you plug in 0.
Yeah.
And then what about the vertical asymptote? Is it the same? Would it be, in this case, the coefficient of a
Yeah,
divided by
Then
coefficient
the
of
horizontal,
c?
horizontal for linear upon linear is that.
Okay. Just for linear though.
Linear upon linear.
If
Only.
it's squared, it's different.
Then it's different. Then you can't do that.
Okay.
True or false?
The graph of a function can cross a no.
No. Vertical asymptote, no.
Yeah.
This it can cross, yes. Horizontal asymptote, it can cross. It crosses the horizontal asymptote, like this one. This is crossing C. Here you have a horizontal asymptote. In this one, there is a horizontal asymptote, and the graph is crossing the horizontal
How
asymptote.
come?
Short distance it crosses. Asymptotic behavior is a long distance behavior.
I don't get that, but it's
But
just something to remember.
There's something to
just there.
remember.
Okay.
Match the feature of the graph which is algebraic equivalent.
Oh, so where the denominator
Use the graph in question 1.
You just match them. 8
Acha, x-intercept?
would be y is equal to 0, so d.
Yeah. Is
Y-intercept.
the value of x-intercept is the value of x-intercept. X-intercept
when y is equal to 0.
when the numerator is equal to 0.
So numerator, yeah.
Is the x value when you make the numerator equal to 0.
Y-intercept is d.
Y-intercept is there.
Vertical asymptote is b.
Domain.
Domain where the denominator cannot be equal to 0. Okay, nice.
The rules of horizontal asymptote depend on the degree of the numerator denominator as we
Right.
discussed.
Okay.
These rules are probably hard to guess. So let's write them together.
You would have done that in the lesson.
So if your y is equal to ax plus b upon cx plus d, it is linear upon linear basically.
It's a upon c.
Correct? Y is equal to a upon c.
Y is equal to a.
Achha, second is if you have y is equal to
ax squared.
ax plus b upon let's say cx square plus dx plus e, then your y is equal to 0.
Which is automatically equal to 0.
Yeah. Achha. And third, if your y is equal to ax square plus bx plus c upon dx square plus ex plus f, then your y is equal to a upon d.
Okay, so what I'm getting from this is that
Huh.
if your denominator is greater than your numerator,
Huh.
it's equal to 0.
Huh.
And then if it's the same, if
Huh.
they're both linear or both quadratic,
Ah.
it's equal to the coefficient,
Yeah,
numerator
linear
upon
coefficient, yeah.
denominator. Okay, that's straightforward.
If a function has a horizontal asymptote, it also becomes the end behavior for the function. So we'll see. I think so. We'll stop here and we'll continue with this tomorrow.
Tomorrow, yeah. Thank you for the extra class, by the way.
Yeah, pleasure.